All right, so today what we're going to do is we're actually going to talk about something called compounded interest. Now, this is this is very much so a financial thing. Oftentimes, savings accounts, checking accounts, that sort of thing. You can, depending on the bank that you choose, what they do is they promise some sort of percentage, and then they say they compound it in some way. Now, what compounding means is basically, let's go back to kind of what we've been doing. What we've been doing is we've basically said, all right, this thing grows exponentially at a certain rate over time. So what we've been doing is we've been saying, all right, look, what if you do 6% annual growth, right? So that just basically means that after every year you grow by 6%. So if I put in $100, after 1 year I have $106, right? After another year, after another year, we do the 106 times 1.06 again, and we get $112.36, right? So the 112, the 12 is easily just the 6% based on that 100, but then you have 36 cents because it's that's 6% of $6. So that's why you would both of those, right? Now, so you make these jumps. So, you put in $100 on January 1st, then on the next January 1st, you're going to have 106. And then on the next January 1st, you're going to have $112.36. However, instead of annual growth, what we might say is we say, okay, look, we're going to do 6%, except what we'll do is we'll do it something called maybe biannual compounding. Basically, what we're going to do is, yes, you start off with $100, but what we're going to do is we're going to have this. So this is what you have at the first of the year, right? But instead of just saying, okay, well, you're going to do 6% every, you're going to do 6% and we're going to give you that 6% at the end of the year. What we're actually going to do is we're going to say, okay, I'm going to actually give you, I'm going to say this grows at 6% per year, but halfway through the year, so July 1st, halfway through the year, I'm going to give you your 6%. So what does that mean? Halfway through the year, though, is on July 1st now, you actually are going to get $103. Because, so if I gave you 6% on $100 for the year, you would have jumped to 106. But since I'm going to do it, I'm going to give it to you biannually, meaning twice a year, what I'm going to do is I'm just going to do 3% for the first half. Now, the next 3% for the second half actually goes on the 103. So by January, in fact, you now have 103. You are in fact going to have 106.09. So if I compound it biannually, I actually make an extra 9 cents. What about the next year? Well, again, now we're going to actually multiply. So again, this would be on July 1st of the next year, so only halfway through, right? We would have $109.2727. But, so when the other person has 112.36, we are in fact going to have 112.55. So we're going to make just a few more cents, right? Not that much, but it definitely is growing a little bit faster. So that's what compounding interest is, right? Instead of growing just like once at the end of the year, you're going to grow at smaller amounts, but you're going to grow throughout the year, right? So that's compounded interest. So let's do an example problem. Or let's actually give you the formula. So the formula for compounded interest is F equals I 1 plus the rate divided by c. We're going to use c for compounding. How many times does it compound per year? Over t times c. C, again, being the number of times it compounds, right? So F equals final, I equals initial, R equals percent rate, T equals time, and C equals number of times it compounds per unit of time. So, for example, let me give you an example here. So let's say you put in, you initially put in $3,000. Okay, so we're going to initially put in $3,000. Let's say that this thing compounds. We'll say it compounds quarterly. Well, if it compounds quarterly, that means C equals 4. It compounds 4 times every year. It compounds each quarter of the year. So that's why C is 4. It compounds quarterly at 5% a year. All right. So let's say we want to know how much do we have after, we'll say after 5, and let's go with 10 years. Okay, so this means that my initial is 3,000. I want to know how much after, so I want to know my final. So final equals 3,000 times 1 plus my rate, which is 0.05, divided by the number of times I want to actually compound this per year, which is 4, to the power of my time, which I've just said is 10 years, right? So 10 years down the road, times the number of times I'm going to compound it per year, which is, again, 4. So here's our equation. Typing that in, so you might want to use a fairly nice calculator here, because but 3,000, then start a parentheses, 1 plus 0.05 divided by 4, close that parentheses, and take it to the power of 40, or 4 times 10. If you do this correctly, your answer is going to be $4,931. I rounded that. So check to make sure you're putting in your calculator correctly. If you're not, just go back and review exactly how to put this in. Hopefully you've got a decent calculator that can do parentheses and that sort of thing. So this is going to be 4,931. Good. Okay. What if I want to know how long till I have $6,000? So how long till I double this thing, right? Well, again, that means how long till I have 6,000 is how long till I end up with 6,000. So that's why I'm going to put 6,000 equals 3,000. 1 plus 0.05 divided by 4, t times 4. So I want to know how the time. So that's why I haven't put time in, right? So now, to solve for time, first thing I'm going to do is I'm going to divide both sides by 3,000. I'm going to get 2 equals. By the way, let's put in, so 1 plus 0.05 divided by 4, by the way, is exactly, okay, so I'm actually going to do this. This is 1.0125, okay, to the power of t times 4, or 4t. Now, once you get to this stage, so I just, I divided both sides by 3,000. I got my 2. I actually did what's inside my parentheses. There it is. Now let's actually solve for t. So t, by the way, is an exponent, so I need to use a logarithm. So this is going to be log base 1.0125 of 2 equals 4t. So if you have a calculator that can change the base, you can just type this in. If you don't have a calculator that can change the base, you want to do log of 2 over log of 1.0125. And that's going to equal my 4t. So let's do that. So we're going to do log of 2, and we're going to divide that by log of, that's a 1.0125. And when we do that, we get an answer of 55.7976 equals 4t. So divide both sides by 4, right? So if I divide 55 by 4, you are in fact going to get, divide this by 4, cancel out over here. We actually end up with t equaling, so let's say to the nearest year, 13.94. So t in fact equals 14 years. So in 14 years, you will have doubled at a 5% growth, compounded quarterly. You will actually have doubled your investment. There you go. Yeah, so that's compounded growth. And let's do one more before I go on to continuously compounding. Well, yeah. Let's compare two. So let's say you want to do, so let's say your initial investment is going to be of $5,000. Okay, $5,000. And you either can do one of two things. You can do, let's say, 5%. Compounded annually, which means C equals 1. Or let's say you can do 4.9% compounded monthly, which means C would be 12. Okay. So how much do you have in 10 years for both of these, right? So we'll do 4.9% over here. So if it's 4.9%, that means your C is 12. So you're saying the final equals your initial, 5,000, times, so 5,000, right? Here it is, times 1 plus your rate, which is 0.049, divided by 12 to the power of 10 times 12. All right. 5% though, this is annual. This is going to be F equals 5,000 times 1 plus 0.05 divided by 1 to the power of 10 times 1. Because again, compounding annually, meaning we're just going to compound it once. So let's do both of these really quickly on our calculator. So 5,000 times, start parentheses, 1 plus 0.049 divided by 12 to the power of, well, 10 times 12 is 120. And our answer is, this thing will grow to be about $8,153 What about that one? Well, same idea, except it's going to be 0.05 divided by 1, so we don't need to really divide that at all, and to the power of 10. When we do that, we get our final to be 8,144. So in fact, compounding monthly did not. Compounding monthly, even though this is a lower rate, compounding monthly actually is better. Oops. Yeah, let me rewrite that so you can read it. 8,144. So even though this is a lower rate, since we compounded it every month, it actually grows faster than a 5% if you just compound it once a year. So in fact, compounded monthly is a little bit better, but obviously these rates are really close. So in any case, so that would be your next example for compounded interest. I'm going to do another video here for continuously compounding, but yeah, so give me a sec.